Gravity is the force that attracts two bodies toward each other. It is a fundamental force of nature, meaning that it is one of the four forces that underlie all interactions in the universe. In this response, I will explain gravity in more detail, including its properties, effects, and mathematical description. Properties of gravity. Gravity is a universal force, meaning that it acts on all objects in the universe, regardless of their size or composition. The strength of gravity between two objects depends on their masses and the distance between them. The greater the mass of the objects and the closer they are to each other, the stronger the gravitational force between them. Gravity is an attractive force, which means that it always pulls objects toward each other. There is no such thing as a repulsive gravitational force. Effects of gravity. The most obvious effect of gravity is that it causes objects to fall toward the ground. This is because the Earth is much more massive than most objects on its surface, so it exerts a strong gravitational force on them. Gravity is also responsible for the orbits of planets and other celestial bodies. The gravitational attraction between the Sun and each planet keeps the planet in orbit around the Sun. Gravity affects the passage of time, as predicted by Einstein's theory of general relativity. Time passes more slowly in regions of strong gravity, such as near a black hole or close to the Earth's surface. Mathematical description of gravity. Gravity is described by Newton's law of universal gravitation, which states that the gravitational force between two objects is proportional to the product of their masses and inversely proportional to the square of the distance between them. This can be written as F equals gm1 m2/r2, where F is the force of gravity, g is the gravitational constant, m1, and m2 are the masses of the objects, and r is the distance between them. The effects of gravity can also be described by Einstein's theory of general relativity, which describes gravity as the curvature of space-time caused by the presence of mass and energy. Here are a few more interesting facts and concepts related to the topic of gravity. The gravitational force between two objects decreases rapidly as the distance between them increases. The force drops off as the inverse square of the distance, meaning that if the distance between two objects is doubled, the gravitational force between them decreases to 1/4 of its original strength. The strength of gravity is also affected by the distribution of mass within an object. For example, if an object is not perfectly spherical, its gravitational field may not be uniform, and the strength of gravity at different points on its surface may vary. The concept of escape velocity is related to gravity. Escape velocity is the minimum speed an object must reach to break free from the gravitational pull of a larger body, such as the Earth. The escape velocity for the Earth is approximately 11.2 kilometers per second. Gravity can also cause the phenomenon is known as gravitational lensing, in which light from distant objects is bent as it passes through the gravitational field of a massive object, such as a galaxy cluster. The study of gravity has led to a better understanding of the structure and evolution of the universe. For example, that discovery of cosmic microwave background radiation, which is thought to be the residual heat from the Big Bang, provided evidence for the Big Bang theory of the origin of the universe. The gravitational force is a conservative force, which means that the work done by the force on an object moving between 2 points is independent of the path taken. In other words, if you lift an object to a certain height, the work done against gravity will be the same whether you lift the object straight up or if you move it in a curved path. The effects of gravity can be observed on a large scale, such as the orbit of planets, as well as on a small scale, such as the behavior of subatomic particles. One of the biggest challenges in physics is to reconcile the theory of gravity with the other three fundamental forces of nature, the strong and weak nuclear forces, and electromagnetism, in a single, unified theory. The discovery of gravitational waves in 2015 was a breakthrough in the study of gravity. Gravitational waves are ripples in spacetime that are created by the movement of massive objects, such as colliding black holes. The detection of gravitational waves has allowed scientists to study the universe in a completely new way and has opened up new avenues of research in astrophysics. In addition to its role in astrophysics, gravity also has important practical applications on Earth. For example, the design of buildings, bridges, and other structures must take into account the effects of gravity on their stability and strength. The strength of the gravity can also be affected by the presence of other objects. For example, the gravitational force between two objects can be altered by the presence of a third object. This phenomenon is known as the three-body problem and is a topic of ongoing research in physics and astronomy. In general relativity, the theory of gravity developed by Albert Einstein, gravity is described not as a force but as a curvature of space-time. According to this theory, massive objects warp the fabric of space-time around them, causing other objects to move along curved paths. The study of gravity has also led to the development of new technologies, such as the Global Positioning System, GPS. GPS relies on a network of satellites that orbit the Earth and uses the timing of signals from those satellites to calculate the position of a GPS receiver on the ground. Because the satellites are in motion and are affected by gravity, the timing of their signals must be adjusted to account for relativistic effects, such as time dilation and gravitational redshift. Gravity also plays a role in the evolution of stars. The gravitational force of a massive star causes it to collapse inward, which in turn generates heat and pressure that can ignite nuclear fusion in the star's core. This process releases energy in the form of light and other radiation, which can sustain the star for millions or even billions of years. Overall, gravity is a fascinating and complex topic with many different applications and effects. From the study of the cosmos to the design of modern technologies, the study of gravity has had a profound impact on our understanding of the world around us. I hope this information has been helpful.